Yeah, we're good? All right, well, let's get started then. So welcome everybody to CMTS 2017. My name is David McPhail. I'm the president and CEO of Memex. Our tagline is measuring manufacturing excellence. That's exactly what we do. We have a booth at 1266, which I understand is way over that way, but on the other side of the show. What Memex does is we measure manufacturing excellence. That's our tagline. We trademarked it. And so what I want to do today is sort of take you on a bit of a journey through data-driven manufacturing and the case for data-driven manufacturing, and talk about how we integrate legacy equipment into corporate networks. So with that, let's get started. This won't be a product pitch. If anybody wants any information on our product, our booth is 1266, or our website is memexoee.com. So here's what we're going to cover. We're going to cover data streams to fuel an IoT implementation. We're going to cover situational awareness in the IoT era. We're going to talk a little bit about the factory of the future, what Industry 4.0 and IoT is, and try to debunk a little bit of that. We'll talk about IT-OT convergence. We'll talk about business use case, OEE, and we'll get to some additional transformational benefits. We'll go through a couple of real case examples with numbers and summary and Q&A at the end. I'll try to keep this to 30 to 35 minutes with a 5-minute question period at the end. So data streams to fuel an IoT implementation in manufacturing. So when we look at this graphic here, we'll start at level 0 being the machine, and level 4 is the ERP system, but there's a whole set of data and applications in between here that actually communicate the data from ERP to the shop floor, and then from what's happening on the shop floor back up to ERP. So we'll talk a little bit about that. This is the ISA 95 standards for data integrity across a manufacturing environment. So we have obviously the machine, the connection. We have distributed control or a server. We have a manufacturing execution system. In our case, we calculate OEE, and then we obviously have ERP. So what drives this need or the drive towards connectivity? Well, when we have customers, suppliers, the shop floor, and management all working with the same data set, we can get higher customer satisfaction. We can lower our costs. Everybody wants to strip out costs. We get competitive agility, and we ultimately get greater productivity. So I want to talk a little bit about MT Connect, but before I do, who here's heard of MT Connect? Awesome, awesome, almost everybody. So before MT Connect, we've been in this business a long time. I've been in this business for 10 years personally. Before MT Connect, we had a bunch of manufacturing equipment on the left-hand side of this slide. We had a bunch of applications that could consume that data on the right-hand side. And then companies like us or other companies would have to come in and write a unique driver for every piece of this equipment. And what that did was it basically tied you from a proprietary solution, and it also was more expensive. So the barrier to entry was much higher before MT Connect. And because if I wrote a driver, I wasn't going to share it with my competitor, and you wouldn't own it because I wrote it. I didn't charge you for it, but I had to do it in order to communicate to your equipment. When we talk about after MT Connect, so a little bit of background of MT Connect. It was started in 2006 by AMT, funded by Association for Manufacturing Technology out of the US. And in 2008, it really started to hit its stride. Memex joined in 2010, and we've been a huge supporter of MT Connect ever since. There's many manufacturers on the shop floor here that you can go and inquire about their equipment and whether it's MT Connect compliant. Mazak is just over here. Neil will be talking about it a little bit later in his presentation. But now what we have is we have a common protocol between the equipment and the consumer layer or the application layer that allows to be seamlessly integrated. So it allows the equipment to be seamlessly integrated and speaks the language of the internet, which is HTTP and XML. So when we look at the 3 pillars of MT Connect, we have the 3 A's of MT Connect: adapter, agent, and application. There's a whole bunch of information on mtconnect.org, on the MT Connect website. As I said earlier, HTTP and XML. And then for legacy equipment, this is what we do. So when we have legacy machines that don't have, in some cases, an Ethernet port or don't have the ability to speak intelligently, we put in a small hardware device, and essentially what we do is turn that machine into a web server. And there's a lot of companies that make hardware that does this, so this isn't me pitching Memex, but just the question I get asked a lot is, how do I connect my legacy equipment? I've got this brand new piece of equipment, it speaks intelligently, but how do I get the data out of the other, in some cases, 70 to 80% of my manufacturing assets? Well, this is one example of how to do it. And what does that look like in terms of legacy connectivity? If you look at these 3 controls, this one doesn't have an Ethernet jack, that one doesn't have an Ethernet jack, and that one doesn't have an Ethernet jack. But we've able to put hardware into these controls and actually pull the data out. And our purpose of using this data is to calculate overall equipment effectiveness, or OEE. But this is an example. We have hundreds of examples of these types of controls, these legacy controls, that we can get some semblance of data from and create a very compelling business outcome with. When we look at the confluence of 3 data streams in order to fuel an IoT implementation, we have obviously operator data. So the human capital that operates the equipment is an intrinsic part of the data flow. We obviously have business systems data. We have all our financial accounting, all of our work order tracking, all of our human resource tracking is all done in our business systems, or ERP. And then we have the machine data. When we put confluence of these 3 data streams together, if we don't have those 3 data streams, we're very reactive when we have operator-centered data and data going into ERP without the machine data or without automatic data collection. When we do connect these 3 business streams together, these 3 data streams together, we can be very proactive because we have real-time situational awareness of what's going on with the human capital, the equipment, and we feed it directly to ERP to do things like drive inventory and procurement. So when we talk about business systems integration, we're talking about obviously linking ERP. We're improving our scheduling accuracy when we do this because nobody has to run around the floor now and figure out where all these work orders are and at what stage of completion they are. We can look that information up directly and we can feed it directly into ERP. We can track our job progress in real time, and we can minimize our work in progress because there's no sense, in a lean manufacturing environment, there's no sense just building piles of inventory everywhere. And to use a Toyota production system, that's called muda, or waste. When we look at how data-driven manufacturing comes alive, well, we obviously need evidence-based real-time data. It's key. It's absolutely foundational. We don't have data-driven manufacturing without it. Work order scheduling and results, as I said earlier, reporting directly to and from ERP. And this whole concept we call the factory of the future. If we really want to get elegant, we can actually have work in progress with RFID tracking so we know where these piles of work in progress are around the factory floor. Some of our customers produce landing gear, and it's 50 operations before the finished part, from raw forging to finished part. And sometimes when you walk on their floor, there's 5 or 10 cradles of parts in various stages of completion. If we put RFID on these, we can track where they are. The forklift operator knows exactly where to take that part to the next order because we have the genealogy of the manufacturing process well understood. So what's the purpose of doing this? Well, we obviously want to drive out costs. We want to lead to higher capacity. Everybody wants to do more with the same level of effort. Process improvement and continuous improvement. There's 3 things that change in any factory at any given time. There's the people, the equipment, and the product that the company makes. And anytime any one of those 3 variables change, and we don't have the situational awareness to know what those changes are, we're not going to produce that part efficiently. We're not going to produce as efficiently as we did before. And if it's a new part or a new product that's going through the factory, we don't have any idea where the benchmark is unless we're measuring this stuff in real time. And then when we have the factory of the future, we can do things like horizontal and vertical integration. So from a horizontal perspective, we can get everybody on the operational management team using one version of the truth. So all the morning meetings, all the Gemba boards, all the things on the factory floor are all driven with this real-time data. And when we have vertical integration, if we have trusted suppliers, things like surface treatment or heat treating, we can actually give them a heads up to tell them that, hey, next Thursday, we're going to send you a batch of parts and we need them back on Monday or Tuesday or Wednesday or whatever the scheduling conflicts and requirements are. So what's the value of production visibility? So when we talk about the how, we're a big proponent of involving the operator. The operator has a huge part to play in the efficiency of the process. And we've been very poor in not giving him the tools to be part of a solution rather than just simply pointing out that there's a problem. So we're huge proponents of involving the operator. Teamwork. It's important that one's version of the truth be used by the entire operational management team in order to get to the root cause and do root cause analysis of production bottlenecks. And then setting your goals and improving them over time is huge. And when we have real-time objective data, we can do that. And then, obviously, we've talked about this before, but adopt the technology so we connect the shop floor to the top floor so we have complete visibility and transparency throughout the entire organization. the when. So in our case, our sales, when we talk to our customers, it's a 10 to 50% productivity improvement, and I'll go into the details of how that comes alive, and a significant increase in income from operations contribution for companies that have gone down this path. And we have case studies of, again, they're on our website or at our booth, usually measured in months. And then using a proven solution reduces the risk, and a systemic cultural change. Culture change and change management is the #1 impediment to the adoption of this technology. People fear change. So how do we get everybody on the same page to be able to embrace this? It really does take a team. It's a village approach. And then if our average internal return rate is 400% or 3-month payback, so if we just were to start this on the first day of your fiscal year, we would have given the capital back to the balance sheet 3 times in the same 12 months. So production visibility on the factory floor. So what does it do? It defines how manufacturers can generate more profit and more margin. Production data captured, sent to management in real time. This is an example of one of our customers where an operator on the floor is actually looking at the actual process in real time and not having to walk to each individual machine. This particular screen is a group of machines operating in an automated cell. And then operational awareness of how downtimes affect productivity. That's a key one. If we don't know, if we're not measuring it, we can't manage it. If we don't know, we can't fix it. This is what Gemba boards look like on the factory floor, driven with real-time data. So again, transparent, accurate, real-time, delivered to the operational management team. Common objective data right across the entire enterprise. There's no subjective data involved here. And then it's been our experience that customers will get a 6 to 10% productivity increase just by giving the operational management team on the floor awareness of what's going on. So without actually running a report, without actually analyzing any data or coming up with a continuous improvement initiative based on the data collected, just by giving people the situational awareness on the floor, 6 to 10% on average. This is an example of one of our customers who actually, this is the operational cockpit for this company. This is all of the data that's going on their factory floor in real time, and they use this, they monitor and use this every single day, every minute of every day to monetize their inefficient downtime. That's another example of one of our customers. Actually, that's Mazak. Neil's over there in the corner. What does situational awareness look like in the IoT era? Well, it could look like this. This is one example. Or it could look like this. Or it might look like this. Or it could look like that. Now I want to talk a little bit about IoT, and Industry 4.0 and what all the fuss is about. And I want to try and distill this down to some simple concepts. So in this particular, I like this stat. I've seen lots of stats. If you read the newspaper or online blogs, you'll see every week seems like there's a different stat about how IoT is going to transform global GDP. But I like this one because it says it's a global issue, and it will transform about 2/3 of the world's output, which is a huge number, 6 to 19 trillion. I don't get fixated on this number. Your reality might be different, but the point is this is very transformative technology in how business currently operates today. This particular stat was by Accenture and Cisco. Industry 4.0, I wasn't around for these two industrial revolutions, but I started around this one and this one. Where we are right now is where the convergence of all of this data into one concept the German government coined as Industry 4.0. When we look at the industrial Internet of Things, this is a graphic that we use to explain our solution stack, or a solution stack in IoT in a business use case. Everything in green is the connectivity from the equipment. And we have, as we said earlier, the ERP data. We have the operator portal. This is an example of one business use case in IoT. You can see a theme here. We're having data from all 3 data streams again. And then some examples of IoT pragmatically used in manufacturing. Well, we're going to concentrate on OEE today, but we could have high-value asset tracking with RFID. We could have OSHA work envelope compliance and monitoring. We could have RFID on finished goods. And energy cost and consumption is a big one, especially here in Ontario with the cost of electricity. These are examples. These are by no means all of the examples of IoT in manufacturing, but these are the examples that are being utilized today and transforming businesses with compelling value equations. We look at the connected manufacturing revolution, where we are from the left-hand side to the right-hand side. When we started with mainframes and micro PCs, and the internet came in around 2000-ish, 1999 or somewhere around there. And then we had universal computer connectivity. Where we are right now is this technological shift where the data-driven manufacturing, connected manufacturing model, in brackets we call that IoT or Industry 4.0, with universal machine connectivity and beyond here, 2017. So when we look at these three concepts, we look at IoT, was coined by MIT around 1999. We look at Industry 4.0, again, German government circa 2010. And then we look at IoT, that concept. Couldn't find a stat on this one. It was either Cisco or GE, I'm not sure which one. But one of the problems that I have explaining to companies, and I ask this question a lot, is I've been told I have to do this. How do I monetize this into a strategy? How do I distill all this information into a strategy that, and a roadmap that I can actually move forward with? And so I want you to think about these three concepts in the form of a convergence into a model like this, where we have consolidated reporting, big data and analytics, corporate dashboards, but it's all driven by real-time data. We call this concept data-driven manufacturing. And when we explain it in the sense of data-driven manufacturing as opposed to IoT or Industry 4.0 or IoT, this seems to be a lot more digestible by manufacturing when we call it data-driven manufacturing, because pretty much the three words say what the concept does. We look at the data-driven manufacturing applied to manufacturing. We have reality versus myth. We'll start with the myths first. Well, the myth, it's a theoretical construct with no practical application, or an unquantifiable business expense with no return on investment, or a highly technical deployment strategy where the technology is unknown, the path is unknown, and both unproven. And the last myth, and the one I like the best, is that it's a magic bullet for every single problem that manufacturers face today. Those are all myths. But what's the reality? The reality is it's both disruptive and transformative in a good way. It's a no and quantifiable payback with a very compelling value equation that can be easily demonstrated. It's practical and proven to be key in eradicating productivity gaps, and it's on average generating about a 300% internal return rate of capital on a global basis, and reality is it's available today. I want to talk a little bit about IT and OT convergence. So when we look at these two camps, one of the biggest, when I talk to customers or prospective customers, one of the biggest complaints I get from OT people, operational technology people, is their number one complaint is working with IT. Okay? And then when I talk about IT, when I talk to IT people, their number one complaint is the guys in OT want to connect the network, but they don't want to do it in a secure way, or they don't want to follow policy and procedure. So these two camps are somewhat polarized against each other, and it's difficult to sometimes get them to talk about to get on the same page and talk about the same things because they see things differently. But they both care about physical security and safety. So nobody wants to needlessly expose their factory or their operations or their manufacturing operations to viruses or any bad malware or ransomware, that kind of stuff. IT is worried about outdated or custom systems. OT is worried about productivity and quality control or data leaks. So these are the concerns that both of these camps have, and they both are vital to the success of an organization. So what really has to happen for this technology to be embraced by these two camps is we need to have, before I do that, look at what they care about. In other words, physically, what does both camps care about? Well, in the case of informational IT technology focused people, they care about the networks, they care about the databases, they care about the applications, they care about the servers. The use of that data in the business outcome case is cared for by OT. So OT cares about shop floor connectivity, they care about applications, they care about transferring programs to and from the equipment if you're a CNC shop with the DNC capability or a requirement. They care about operational situational awareness. When you look at what has to happen, these guys have to get on the same page, and we try to do that. We try to broker the arrangements between IT and OT to do this in a secure way where internet security is the number one foundational piece. I mean, this has to be done in a secure way. Neil will go into some more detail when he does his presentation a little later on today. But obviously we can encrypt the data between all the devices. We can ensure integrity from these systems. And then we basically ensure that the updates, all updates, whether it's firmware to hardware or application updates, are done in a secure way to keep the company ahead of the curve. When we look at areas to explore for benefits, we're going to talk about overall equipment effectiveness. Who here has heard of OEE, or who here tracks OEE in real time? In real time? Do you track it in real time? So we look at critical business challenges. We're talking about rising business costs, obviously visibility of shop floor operations, productivity and asset utilization is important. Data collection accuracy, this is a big one. If we're collecting data but it's not accurate, it's not valid. We're going to make poor decisions based on poor data. Everybody wants to integrate the business system because it just makes life easier. And then continuous improvement initiatives like TPM or Lean or Hoshin Cannery, these are all much more effective when they're driven by real-time data because we make real decisions with real data that's accurate. So why does OEE matter in the IoT era? Well, it's becoming one of the most important metrics in manufacturing because for the first time we can distill the manufacturing process down into a number. World class is 85%. That's 95% in each of the categories of performance, quality, and availability, multiplied by each other. So when we look at availability, we're looking at runtime divided by total time, including downtime, never more than 100%. When we look at quality, we're looking at good parts divided by total parts produced, which include rejects. Again, never more than 100%. But when we look at the performance, that's the speed rate of the actual equipment. So if, for example, your cycle time, just pick a number, say 5 minutes. If your cycle time is 5 minutes, did you make that part in 5 minutes? You're 100%. If you made that part in 3 minutes, you're 166%. If you'd made that part in 10 minutes, you're 50%. So this is the one number that can change over time based on process improvement, based on, let's say you tried a different tool, a new tool came out and you tried it. We had an actual customer that did this. We had a customer that makes bearing races for downhole drilling tools with Rockwell 56, very hard material. And a tooling supplier came in and said, I got a particular type of, and I'm not a tooling guy, but I'm gonna say cobalt something or other, some kind of heavy, hard material that could take the part faster. Instead, he could ramp the feed rates by 20%. So he said, great, bring it in tomorrow and we'll try it. And they did. They actually were able to ramp the feed rates at 20% and keep the quality, and because they knew that it was 20% because they were measuring it in real time. And now you can make simple decisions about what's the cost of the incremental cost of the tool and how many more parts I can make during a day and what's the value returned to the company based on the effort expended and the money spent. What drives the desire for OE? Well, that's a big one. We're replacing subjective data with objective data. We call this shining a light on all the dark assets that exist. Take lean productivity and lean manufacturing concepts to the next level. And this, to sum up these three, essentially reveal your hidden factory. What are the roadblocks to look out for when you do this? So when we used to go to market, say 3-4 years ago, we would spend a lot of time talking about the how. We'd spend a little bit less time talking about the what, a little bit less about the when, and we'd spend the least amount of time on the business case or the why. And what we found was that was great for educating people, but it didn't move people from thought to action quick enough. So we changed our business model and we talk about the why first. And we never get to talk to the customer about the how until we get the why well understood. And the why is the business use case. What's the hard numbers with respect to what is return on investment for effort expended? So we spend a lot of time on this because I don't know about you, when I go to want to buy a new car, I don't buy a new one that often, but when I do, what's the salesman want to do first? He wants to put me in the driver's seat. He wants me to envision myself driving that car. And that's what we want to do with our customers. We want to help them understand the financial benefits, the transformational benefits associated with the adoption of data-driven manufacturing before we ever talk about what size of server we need or what's a network and all the other associated pieces on the how side. So the why is the most important thing to talk about. Because you won't get funded otherwise. If you take this to management for a capital appropriation request, if you can't articulate the business case, the project doesn't get funded. So the why, focus on the business case. Competitive advantage, we have to consider status quo is not acceptable. As I said earlier, culture of the company and change management are the two biggest challenges that most companies face when they adopt this technology, so that needs to be taken into consideration. And then this one's a big one, too busy with tyranny of the immediate. So I've already got 5 jobs, why do I need another one, right? So these are things to consider when you're considering going down this path. I want to talk a little bit about fear, uncertainty, and doubt. So on the fear side, we're talking about fear of failure, fear of data system security, fear of the unknown, and fear of change. When we're talking about uncertainty, we're uncertain of the path forward, we're uncertain of the quantifiable results, we're not sure how this fits to our business. And then the doubt. Doubt that the promised business outcome, what the salesman told me is actually going to be true, or I have doubt that I'll be able to change the culture of the company sufficient to change, to handle the change management and actually adopt and harness these types of technologies. These are things to all be concerned about. We call it FUD, fear, uncertainty, and doubt. But unfortunately, when we get the doubt plus the uncertainty and plus the fear, we end up with what we call the analysis paralysis problem. Because then we don't act, we have endless paralysis, and most importantly, we have a lot of lost opportunity cost. Because if you believe what I said about a 300% internal return rate or a 4-month payback, for every 4 months that we don't do this, we're losing a potential on 100% of what that project would cost returned to us on our balance sheet in the form of capital. So I want to blow through a couple of examples here with real numbers so you can see how compelling this value equation is. So the factory on the left is the actual factory. Most of the times when we start with companies, I ask them what their percentage of efficiency is. They tell me it's 65%. We know there's room for improvement. We've done this 150 times. In every single case, we're sub 40%. The actual number is sub 40%. So we have a perception reality disconnect from how efficient we think we are versus how efficient we actually are. The factory on the right is a factory that's embraced data-driven manufacturing and calculates OEE and is now up in the world-class level of around 80 to 85%. And they've minimized all of these losses, small stop, speed loss, downtime, setup, and maintenance, are all now within a manageable amount, as opposed to taking over the majority of the 100% of available time the equipment's ready to produce the part. When we look at the 10 to 50% productivity increase, there's no one magic bullet. Every single one of these buckets, reducing downtime, minimizing rejects, root cause analysis, and on, are all small little incremental changes. But because we can see them now, because we have root cause analysis, we have the ability to see right in front of us what's going on, we can make these small little changes. When you look at a Kaizen event as an example, what do we do if it's a Kaizen event, it's a 4-day event? What do we do for the first day and a half and the last half a day? We collect data. We collect data to figure out what we're going to do when we analyze that data, pick a continuous improvement initiative, implement it, and then measure the results. Was it accretive, was it neutral, or was it negative? That goes away when we do this in real time, because now we can see this stuff in real time and we can target continuous improvement initiatives immediately. And again, these all come in little small chunks. There's no one magic bullet. You're not going to find one thing on your factory floor that's like 15% or 20%. It's going to be 2% here, 3% there, 5% there. Here's an example of a small medium enterprise, 10 machines, 5 days a week, 8 hours a day, loaded labor cost of $85 an hour. We're going to, for the purposes of costing the project, we're going to talk about 10 machines in total, and 5 of them are hardware connected, so we need to physically put a hardware device in there. This is pretty common in terms of numbers. We're going to talk about a very conservative 3 minutes for reducing downtime and 2 minutes for increased visibility. Remember I said and-on screens give you 6 to 10%. And so this adds up to about an 8% increase in OEE, a very small conservative number. We look at the cost of this project, we would have spent $63,000. We would have given back in the first 12 months $142,000. Our internal return rate was a little bit greater than 200%, and our payback was a little less than 6 months, but over 3 years we would have given back $452,000 to the company. We'll pick an example number 2. We'll pick a little larger shop, 30 machines, 5 days a week, 16 hours a day instead of 8, same loaded labor cost. Again, same split, 30 machines, 15 are hardware, same 3 and 2 minute incremental or 8% OEE increase. But what does this one do? Well, we would have spent $149,000 on this project. We would have generated $850,000 in the first 12 months. Our internal return rate is greater than 400%, less than a 3-month payback. In the 3 years, we would have generated $2.5 million of additional income to the company's bottom line. Additional transformational benefits. So connect any machine, monitor and assess productivity, identify bottlenecks, analyze root cause analysis, and discover the hidden factory. These are all impactful continuous improvement benefits. These are just a selection of different industry verticals and different numbers. I'm not going to read them, but you can see the numbers. It's a very compelling value equation. 25 to 60% OEE, or a 25% overall improvement. These are all actual numbers from case studies that we've done with our customers. Again, here's another example, 40% gain, 11%. These, again, big numbers. It doesn't take a big number to create a very compelling value equation. So in summary, 300% IRR, the payback is known, it's proven, it's available today. The why should always be the first discussion. Security is important, and there's a direct link between increased productivity and increased profitability. With that, I'll take any questions anybody has.
Check.
Anybody have any questions? Awesome, thanks for your time.